In today's class, I will discuss with you the basic concept of wind energy. A small portion of the total solar radiation reaching the Earth's surface causes the movement of the gas molecules in the atmosphere. This motion of the gas molecule is called the wind. As such, the energy in the wind comes from the solar energy. The wind power is self-renewing energy sources which will provide a continuing supply of non-polluted energy for future generation. Though wind energy may be available throughout the year, its quantum may vary from time to time. As such, it is very vital to determine how much energy is available in the wind at any time before designing the windmill. The wind is a clean, free and readily available renewable energy sources. Each day around the world, wind turbines are captured the wind power and converting it into electricity. Wind power generation plays a increasingly vital role in the way we power our world in a clean and sustainable way. Now, how a wind energy is created. A wind turbine converts the kinetic energy of the wind motion to mechanical transmitted by the shaft. The generator is coupled to the shaft further convert the electrical energy, thereby generating the electricity. That means the wind turbine allows us to harness the power of the wind and turn it into the energy when the wind blows. The turbine blades spin clockwise, capturing the energy. This triggers the main shaft of the turbine connected to the gearbox within the nearest to the spine, and the gearbox send the wind energy to the generator, and inside the generator the mechanical energy is converted into electrical energy. The electrical output then connected with the transformer where the voltage levels are adjusted by synchronized with the grid. So the main objective of the wind generation is that at first the wind turbine is coupled with the alternator and whole systems are installed over a certain height with a tower. When wind blows, then the turbine rotates, then the kinetic energy of the wind is converted into the mechanical energy inside the turbine, and turbine is coupled with the alternator or generator. And we know basic principle of alternator is that it converts the mechanical energy into electrical energy. So the output of the wind turbine energy, that is the mechanical energy, is converted into electrical energy inside the alternator, and finally the voltage is adjusted by the help of a transformer for the grid. And when the energy is adjusted, attached with the grid, then the transmission and distribution systems are started from there. Now, the power in the wind. Windmills convert the kinetic energy of the wind into mechanical energy. The total power of the wind system is equal to the time rate of the kinetic energy. So the kinetic energy equals to half mv squared. That is the equation 1. The amount of air passing the unit time through an area A within a velocity v equals to a into v. Therefore, the mass m equals to rho a into v. That is equation 2. Where rho is the density of the air particle is kg per meter cube. Therefore, the kinetic energy per unit volume equals to half rho v squared. That is equation number 3. Now, from equation number 1 and 2, the kinetic energy half rho a v cube watt. That is equation number 4. And therefore, the total power, that is denoted by P total, equals to half rho a v cube in watt. That is equation number 5. From equation 5, wind power is proportional to the intercept area. The windmill with a large swept area has higher power. Normally, area is circular with diameter d. Thus, A equals to pi d square by 4. Then Pt equals to half into rho into v cube into pi d square by 4, and that is equals to 1 by 8 by d square by d square into v cube. That is equation number 5. From equation number 6, equation number 6. From equation number 6, it is clear that the power is proportional to the square of the diameter of the swept area. Now, the selection of location of site of the windmill. The maximum utilization of the wind energy, the windmill must be installed in a place which satisfy the following requirement. First point, the site must have the high average wind speed throughout the year. Next, the site must be free from any obstacles for above. Next point, top of a smooth well-round hill with the clean area. Next, the island in a lake or sea. Next, mountain gap which produces the wind continuously. So these are the selection of site. Now, the merits of the wind power generation. First point, it is renewable and not depleted with use of like the fossil fuels. Next advantage, the wind is available in the everywhere throughout the world. And another advantage is that wind energy generated and eco-friendly and does not pollute the atmosphere. That is very simple. No fossil fuels are there, so no smoke, no ash is generated from the windmill. Next point, the cost of installation of wind power plant is comparatively lower than the other type of power plant. Next, wind energy can be provided in any remote area. So these are the advantages of the wind power generation. Now, the wind power plant. The kinetic energy of the wind can be changed into the other form of energy, either mechanical or electrical energy. Conversion of the kinetic energy of the wind into mechanical energy that can be utilized to prefer useful work or to generate the electricity. The kinetic energy is given by Ke equals to half mv square, where m is the mass and v is the velocity of the wind. Also, m equals to rho av, where a is the swept by the rotating blades of the windmills and rho is the density of the air. We already discussed about that. Therefore, kinetic energy equals to half rho a v cube watt, or kilowatt equals to half rho v cube watt per square meter. The efficiency of the windmill is a function of the density, volume and velocity of the air as well as the rotor diameter. In other words, the power generated is equivalent to the difference between the kinetic energy entering the windmill and which the passes from the exhaust streams. Now, the types of wind power plant. Basically, the windmills are two types, namely horizontal axis windmill and vertical axis windmill. They can be either lift or drag forces of the wind energy. The majority of the modern windmill are the horizontal axis windmill. The horizontal axis windmills, the axis of rotation of such machines is parallel to the direction of the wind. In modern horizontal axis machines, 3 blades or 2 blades rotors are mostly used. The horizontal axis windmills are also called the wind axis mechanics or machines. The vertical axis windmills are also known as the cross wind axis machines. Here, the axis of the rotation is perpendicular to the direction of the wind. The vertical axis windmills are cheaper and require less structural support because heavy components cannot be located at the ground. The vertical axis windmills are to be more difficult to control in strong wind. So, generally, the horizontal axis windmills are used to generate a huge amount of wind power. Now, the wind power plant are classified according to the power output. Like small wind power plant with a power output of 10 to 50 kilowatt and a rotor diameter of 1 to 16 meters. Next, second one is the medium size wind power plant with a power output of 50 to 500 kilowatt and rotor diameter of 16 to 50 meters. And last one is the large wind power plant with a power output of 500 to 5000 kilowatt and the rotor diameters of 50 to 130 meters.